Lesson 4.1, Graphing Polynomial Functions. A polynomial function in one variable is a function that has only one variable, so only x or only y. And there are powers of that variable, and all the powers are positive. So we have exponents, and all these exponents are positive. Such as this. This is an example of a polynomial. There's only one variable, x, and it does appear 3 times, but it's still just x. And it has exponents, but those exponents are positive. This is another example of a polynomial in one variable. This is not a polynomial in one variable. Why? Because this is the same thing as 2x to the negative 1. That is a negative exponent, not a positive exponent. And this one's not a polynomial in one variable. It is a polynomial, but not in one variable because there are, in fact, 2 different variables. The degree is the highest power of a variable. Or if you like, exponent. So what is the degree of this polynomial? So we'll look at all the exponents and pick the highest one. That's the highest one. So our degree is 3. We can use the degree to classify polynomial functions. If the degree is 0, then we say it's constant, like y equals 2, and that graphs a horizontal line. If the degree is 1, it's linear, like y equals 2x plus 1, which graphs a line, slanted line. If the degree is 2, it's quadratic, which graphs a parabola. If the degree is 3, it's cubic, and graphs look something like that. And if the degree is 4, it is quartic, which can look something like a W. We can evaluate polynomials using something called direct substitution, which is simply plug it in. So if I want to find f of 3, notice that was the x, so we're going to plug it in for the x. So f of 3 will be, just plug in the 3 for the x. And work it out. Order of operations says do the exponents first. 3 cubed is 27. 3 squared is 9. Then we multiply. 4 times 27 is 108. 2 times 9 is 18. 2 times 3 is 6. And then add all those together. We get 137. So f of 3, which means it's the function f when we plugged in a 3, is 137. All right, so we're leading to graphing here. So that substitution, direct substitution, is so we can make a table. And when we're graphing, it's nice to know what the ends look like. Polynomial functions always go towards infinity or negative infinity at either end of the graph. So in other words, they're either going up or down. And we can tell by looking at the degree and the leading coefficient. If the degree is even, the leading coefficient is positive, both ends go up. If the degree is even and the leading coefficient is negative, that's the negative a, flips it over the x-axis, both ends go down. If it's an odd degree, positive leading coefficient, the left goes down, the right side goes up. And if the leading coefficient is negative, left side goes up, right side goes down. We're going to write this like this, as f of x approaches positive infinity as x approaches negative infinity. So this is y goes up as x goes to the left, and f of x goes to positive infinity, that's up, as x goes to the right. The only thing you are changing is there. So the first one is what happens on the left, does it go up or down? And the second one, what happens on the right, does it go up and down? So if it goes up, it's positive infinity. If it goes down, it's negative infinity. And again, this is what happens on the left. This is what happens on the right. So this is up on both sides. This is the even degree. Positive leading coefficient. So how do we graph polynomial functions? First, make a table of values. It'll be a lot of values, not just 5 points. It'll be a whole bunch of points, maybe 10 or 12. A good thing you have a calculator to make the table of values. And then you're going to plot points. And then finally make sure your graph matches the appropriate end behavior. Do both ends go up like they should, or one up, one down? You know, which way should it go? All right, so let's graph this function. So I use my calculator and I make a table of values. And that is and so that's what I get. Let's check end behavior. So I make sure it looks right. End behavior. It's an odd degree because the degree is 3. And it is a positive leading coefficient. So odd degree, positive leading coefficients like that. Goes down on the left, up on the right. All right, so let's see. There's a lot of big numbers, so maybe I will count by 2's in the y. But only 1's in the x's. So -3, -37 is still not going to fit. But -16 is not. So -1, -7 will be right there. 0, -4, 1, -1, 2 and 8, and then 3 and 29. So that'd be way up at the top. So remember, -2 is at -16, which is way down. So it's going to be coming up like this, going up very steeply through there. And that's the graph. Notice the left end goes down, the right end goes up, just like our end behavior predicted.